We don't need it. Okay, yeah, so the topic is 7.9, skipping a few sections, just a couple, you know. It is called geometric sequences as exponential functions. If I can see. Really, it's just geometric sequences. So we talked about already earlier on in other chapters arithmetic sequences. Does anyone remember what an arithmetic sequence is? Arithmetic is one word, and a sequence means something else. Do you remember what the word sequence means? Yeah, we did have to do that. What does a sequence mean? Yeah, that's literally the definition. That sounds like you read it to me out of a dictionary. A set of numbers in a particular order. Arithmetic means they're added together. Geometric, we are going to use multiplication. Okay? So that's literally the difference. And sometimes they'll ask you to determine what kind of sequence it is, because we've already learned, I don't remember what chapter it was, honestly, on the top of my head, but we already learned about arithmetic sequences. So the first part, it says, obviously, a geometric sequence. Right? Uses multiplication. Oh, I'm not going to fit it. Oh, man. Between each term. To find the next. We have to have this other word, or the set of words. It's called a common ratio. We represent with the letter R. That's the first part. Okay. And then second thing is R is, that doesn't look like a dot. Okay. R is the second term divided by the first term. So it is how we get from one term to the next. So if we can't figure it out, we'll take the second one, divide it by the first one. We'll see if you can't look at it and go, how does this multiply? We can use some division. We can do the opposite to figure it out. Okay. First part, I'll just already use a new board. It makes my life a little easier. First part says, determine whether each sequence is arithmetic, geometric, or neither. Determine if each sequence is arithmetic, comma, geometric, or neither, period, and then it says explain. In math, for the most part, when it says explain, right, showing your work is explaining. See if I can turn this light off. We can still see it because light's a little small. Okay, so for example, first one, we have 256, comma, 128, comma, 64, comma, 32, dot, dot, dot. So it goes on forever. We just don't know what it is. So we're going to test all three of these. We're just going to start with geometric. If that works, we're done. If it doesn't work, we'll try the next one. So what you're going to do is you're going to take the second term and divide it by the first term. So you just use your calculator. See what that answer is. 128 divided by 256. I just typed it in. What did you get? I'm going to write it as a fraction. 128 divided by 256. You divided the wrong way. 1 over 2, which is 1/2, yeah? Now, test the next one. If this is a geometric sequence, all the differences will be exactly the same. So then try 64 over 128. See if you get the same fraction. Okay, that's good. If the last one is good, then yes, it is a geometric sequence. 32 over 64, is that 1/2? Okay, since these numbers are all the same, that is R. R is 1/2. That means all numbers are the same. Yes, this is geometric. This is a geometric sequence. Explaining, this is my explanation. I showed my math here. I said, hey, R is 1/2 each time. They're exactly the same. If this wouldn't have worked, we would have seen if when we subtract them, if they're all the same. Does that make sense? So we try the opposite, see if it works. Another one. Okay, leave this. Okay, how about this guy? 4, comma, 9, comma, 12, comma, 18, dot, dot, dot. I always try geometric first because that's our new one. So divide them. 9 divided by 4. Second divided by first. What's that as a fraction? 9/4. Right? Exactly what we typed in. We'll see if the next one is exactly the same simplified. If it's not, we can stop. Is it exactly the same? No, this one's 4/3. So since these numbers are different, can this be a geometric sequence? Nope. Okay, I'm just going to put a little X on that. Now I'm going to try arithmetic. Now again, arithmetic uses addition. So what's the opposite of addition? So now subtract them. If you need to write them again, you can. So you can see your numbers. So then do 9 minus 4. What do we have left over? Okay. Now do 12 minus 9. What do you have left over? Oh, are those the same? Is 5 and 3 the same number? Heck no. So is this a geometric or an arithmetic? So what answer are we going to write? Look back at the instructions. Neither. It is neither. It is neither a geometric or arithmetic. Again, explaining, this is my explanation. I'm showing my work. So if you can't show your work, how would I explain this in words if I had to like type a sentence? How would you explain that geometric didn't work or that arithmetic didn't work? What is this called? What the change from one to another? What was that? What was that vocabulary word called again? That's what a fraction's called, correct. What's one of the vocabulary words I gave you at the beginning of these notes? A common ratio. So you would have to say, if you want to explain it in words, the common ratio was not the same. So if you want to write that down as an example, the common ratio was not the same or was not consistent. So if you couldn't say, just so you know how to say that in words, if they asked you, right, like on Alex or on a state test, right, how to explain it, so we know. Okay, let's try one more, right? We'll have you do it. Ooh, I'm throwing things now. Number 3. How about -20, comma, -15, comma, -10, comma, -5, dot, dot, dot. It's a little crooked, but it's okay. Always try one, then try the other. Foot's cramping. Do we figure it out? So is it a geometric sequence? No, it's not. Numbers are different. Is it an arithmetic sequence? Yeah, what's our ratio? What does it change from every single time? It changes 5. Arithmetic technically they use the letter D, but it's okay. So what would we write if we had to say it in words? This is an arithmetic sequence. With a common ratio. Oop, I don't know what I'm spelling. Yep, with a common ratio. I would say, so you can say this is arithmetic sequence, and you period, you say with it that the ratio is the same, or you can say with a common ratio of, and you can say what it is. That could also work, right? You could say what you found. Right, so this is an arithmetic sequence with a common ratio of 5, or this is an arithmetic sequence. It has the same common ratio all the way through. Whichever works. Does this make sense? This part good? Okay. Let's talk about the next part. Next part is finding the next 3 terms. So you're going to find the next 3 terms of the sequence. Of each, and I'm pretty sure it says geometric sequence. So number 1, we have this sequence. 1, comma, -4, comma, 16, comma, -64, comma, dot, dot, dot. There's a lot of noise going on over there. Okay, so we want to find the next 3 terms. So if I had paper, right, I would go, okay, I need 3 more numbers after this. Well, to be able to find these numbers, I need to know how does it change from one number to another. It tells us it's a geometric sequence. So you only have to figure out how it goes from one number to the other once. Well, how do you get from 1 to -4? Can you tell that in your head? Yep, R equals times what? -4. If you don't believe me, take -4 and divide it by 1. Or 16 divided by -4. So what are we going to do to find this first blank? Yep, -64 times -4, because that's what our ratio is. So -64 times -4, what do we get? 256. Now what am I going to get? How am I going to get the second problem? Yep, times -4. If you have a calculator, just put times -4 and it'll substitute that number right back in. What's that big number? Negative 1024. And then how do we find the last one? Again, times -4. And we're going to get 4,040, 9-6. They must be playing a review game over there. They're getting a little crazy. Is that pretty easy? The only time it gets maybe a little difficult is when you have to pay attention if there's fractions. Like so. 9, comma, 3, comma, 1, comma, 1/3, comma, dot, dot, dot. What does R equal? What are we multiplying here? Remember, you're not dividing. You say times this, not divided by this. And unless it says using decimals, which it usually doesn't, you always write it in fraction form. So what is R? 9 times 3 is 3. Remember, if you don't know it, you take the second term, divide it by the first term. What's 3 divided by 9? As a fraction. 1/3. You're trying to go the wrong way. So R is 1/3. So when you type this into your calculator, right? My last number is 1/3. I have 1/3 in my calculator times 1/3. Put it in parentheses. Math fraction. What's 1/3? What's the next number after 1/3 then? 1/9. 1/9. I always use the line as a fraction bar. I don't know why, I just always do. What's after 1/9? 1/27. That's a little big. Did we get 1/27? Okay. What's after 1/27? What do you notice about the denominators? They're timesing by 3. See how the 3's in the bottom? You're really just timesing the denominator by 3. If you can't do fractions well in your head, or if you think you're wrong in the calculator, you can always go, let's just check that denominator. I really just multiplying by 3? Oh, I am. Well, then I know I'm doing it right. Does that make sense? Remember, fractions. You do get penalized for putting things in decimal form when it does not tell you to. Okay, I need a drink. Okie dokie. Now let's talk about what Lexi was talking about earlier. And the last thing. Now we want to talk about the equation for the nth term of a geometric sequence. Sorry. Okay, here is the formula. A sub n equals A sub 1 times R to the power of n minus 1. We got to talk about what all these things mean. The one we know, what does R stand for? Common ratio. A sub 1, does anyone know or remember what A sub 1 means? Think about a sequence. Think about this sequence. It is. A sub 1 is the first number. So first term in the sequence. Yep, that is what A sub 1 means. Oop, sorry. Then wake up my computer. N is the term we're looking for. And we use this equation because if I said, what's the 100th spot? We wouldn't want to do this times 100, right? We wouldn't want to do that another 96 times. That would take way too long. It'd be too much energy. Last one, A sub N. Can you guess what that means based on what those two things mean? Huh? Close. Well, kinda. It's the answer for the nth term. Because the 1 right there in A sub 1, that's 1 means the number, the term. A means answer. So A sub 1 here is 1. So A sub N would be whatever the actual answer is. So using that, we're going to do a couple examples, and then I'll let you do some board work with all the different stuff we've learned. Okay, so let's start with, let's do a light one. Let's start with an easy one. Let's start with 2, 4, 6, 8. Comma, dot, dot, dot. You know? Something light, something easy. Get the ball rolling. Okay, looking at this. That's our sequence, okay? Now, looking at this sequence, do we know what R is? How do we get from one thing to another? Oh, wait, I'm an idiot. Let's try that again. I was doing arithmetic, not geometric in my head. Silly Miss Rinaldi. How about that? Now I'm not being a silly Billy. Huh? Yep, times 2. Everything should be times something because it's a geometric sequence. I'm just losing my mind. Do we know what the first term is? A sub 1. 2. Do we know what n is yet? Did I ask you for anything yet? So does that mean I know what my answer for n is yet? So that's the stuff we're missing. So then I'm going to say, can you find the 15th term? What is this going to go in for? N. N is going to be 15. Because you need to have all but one thing about all your variables, so you can plug that in. So now let's plug our numbers in into our equation. So we still don't know what A sub n is. Equals A sub 1 times R, which is also 2, to the n minus 1, which is 15 minus 1. Yes? We get where we're plugging all those in from. I would just simplify it first. Every time I plug it in, I go with 15 minus 1, that's really just what? 14. And since all my numbers are on the same side, right, there's no variables over here, just type that bad boy in. 2 times 2 to the 14th. Make sure the 2 the power is only on that 1 2, not both of them. And push enter and see if you get the same big number that I did. See how I typed it in? Did you type it in the same way? Did you get the same answer as me? Is that pretty easy? So then over here, I'm going to write my answer. 3, 2, 7, 6, 8. And then I'm going to be a smarty pants and I'm going to put a comma where it belongs. Oh, Kimber, it's time for the hiccups. Okay. Now, I could just give you information. Here's another example. I'm going to say, look at what your homework is. La, 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 la. Find, I can't spell, but it's fine, the 10th term of, and then it just lists this, 72, comma, 48, comma, 32, comma, dot, dot, dot. That's all it gives us. So we need to gather information we know. As a reminder, I'm just going to write down the formula we have. Now we need things for all but one of those variables. What is a sub 1? 72. What's r? That's the thing we got to figure out. It is 2/3. So that parentheses are really going to help us when we have fractions, aren't they? Do we know what n is? 10. 10th terms means 10. That's enough information, isn't it, to type in our equation? Okay. A sub n, I always write it just in case, is 72. Put parentheses around the thing that has the exponent. So parentheses around 2/3 to the 10 minus 1, which I just write away. I'm going to write 9. And I'm going to grab my fancy calculator. And I'm going to try not to mess it up when I type it in. Parentheses, 2/3 to the 9th. Make sure it's typed in right, because we've all made mistakes. Ooh, that's ugly. Oh, that's really ugly. What is that ugly answer? Did you guys get an ugly fraction too? Oh boy. What's the numerator? That's the denominator, sweets. Okay. 4096. Denominator 2187. You said it so confidently too. It's okay. Did you get the same fraction as I did? Does that make sense? Okay. It may sometimes always, it may just also just give you bits and pieces. Last type of example, it may say the first term, oh boy, of the geometric sequence is 5. I'm making this up. And the common ratio is 9. Period. What is the 8th term of the sequence? So it looks like a word problem, right? But it just gives you all the information you need. By the way, this can't be a pretty number because I picked 5 and 9. So, thinking of this formula, can we plug in where? A sub n stays there. What are we going to plug in for a sub 1? 5, so 5 goes in front, times. What's our r? 9. What's our n value? 8, so n minus 1 is 7. This can't be good. It's a big number, isn't it? That's going to be a big, whew, oh man, that's a beaut. And then comma, comma. That's not as bad. You just never know. I can tell you that I'm looking at some of the answers in your homework, and 26 is 1 decimal place less than this. 27 is 1 decimal place more than this. 28 is the same amount of decimal places. 29 is 1 decimal place less than this. So I'm going to say, yeah, this is about normal. It's because it's geometric, and geometric means multiplying, so the numbers get big real fast. Or then get real small real fast, like that ugly fraction we had that we forgot what the numerator and denominator were, right? So pretty easy. Just have to pay attention to what it's asking you, right? Read the instructions. We can do this. Okay, we are going to do the practice problems if you want to see them ahead of time. These ones have some ugly fractions in them. We're going to do practice problems together. We're going to do them on the board. And your homework is 14 through 29. I'm going to do 1 through 12 with you from that same page, but on the board with you. Okay.